Okay, so we want to find the inverse function of f of x equals 1 plus the fifth root of x minus 2. How do I proceed? That is the first step. It's a 4-step procedure. So y equals 1 plus the fifth root of x minus 2. Next step. Yes, swap them. 1 plus the fifth root of y minus 2. Now what? Subtract 1. And then raise both sides to which power? Fifth power. So then x minus 1 to the fifth equals y minus 2. Final step, y equals x minus 1 to the fifth plus 2. And this is f inverse. Please remember the procedure of finding f inverse. Okay, I want one more problem here and then we can move on. Problem 91. Any questions on this problem? Okay, 91. In 91 we are given f of x equals x squared minus 4, and they say x must be greater than or equal to 0. Sketch the graph of this function and then sketch the graph of f inverse and find the equation for f inverse. What is the domain of x squared minus 4 in general? The domain of x squared minus 4 in general. All your numbers, it's a polynomial function. Why do you think we have this restriction? Why did they bother to say, okay, you're given x squared minus 4, but you can only use x to the right-hand side? Because it will not be one-to-one. This is not a one-to-one function. This one is. Right? From here, there. But this one is not. So we had to truncate, we say, the domain. Good. Excellent. So now, because I know how to graph this, right, using transformations, I know that this is x squared. And x squared minus 4 would be this, right? But I am told x greater than or equal to 0, so this part does not exist. And now this function is one-to-one. So the function is defined on 0 to infinity. Can anyone give us the range of this function? Right. -4 to infinity. Although we don't even know the inverse function, but I already know the domain of this function, the inverse function, and also have its range. What is the domain of inverse function? Of course. What is the range of the inverse function? That's it. So when we're done and we're going to graph, I know what to expect. Good. You can find the inverse function first if you want to, or simply graph it and then find it. Okay, so I already know how to graph x squared minus 4. So I'm going to find a couple of ordered pairs. I know the vertex is at 0, -4. And I know that x squared minus 4 is 0 when x is 2. So I have no doubt that this is the function x squared minus 4 when x is greater than or equal to 0. I know that the inverse function must reverse the coordinates, and it will definitely be symmetric with respect to the line y equals x. Can anyone give us 2 ordered pairs, or give me 2 ordered pairs so I can graph the inverse function? One of them I already know, because this point has x and y the same value. So if I reverse the coordinates, I still have to have the same point. So then, give me 2 other ordered pairs. This point reflected goes where? It was at 2, 0. Where will it go? 0, 2 indeed. This point was at 0, negative 4. Where will it go? Negative 4, 0. So this must be the graph of the inverse function. F inverse, and I'll come back and fill it in. They have to be symmetric at all times, symmetric with respect to y equals x. Good. So now let's find the inverse. So I have y equals x squared minus 4. Then x equals y squared minus 4. Then I have to add 4. And now I take the square root. And I get y equals plus or minus the square root of x plus 4. And I say, no, only one of them. And I go back. And I know that the domain is negative 4 to infinity, which makes sense. X plus 4 has to be greater than or equal to 0. And the range must be a positive number. So therefore, I know exactly which one to pick, and I know exactly which one is F inverse. Very good. I think chapter 2 is pretty much done. I'm really hoping that you are going to redo the problems on each test, right, and review the tests. Okay, so let's look at, yes, of course, don't forget about modeling with functions. We did all of those problems on page 221. So please look at few so we can look at chapter 3 now. In chapter 3, we graphed quadratic functions, cubic, 4th degree, polynomial, cubic, 4th degree, 5th degree, 6th degree, and rational functions. So I'm on the last page of the review exercises. On page 293, we can graph a polynomial. I hope that the quadratic doesn't need to, but we can. So we can graph a polynomial, a rational, and then we can move on to chapter 4, exponential and log. Okay, so please tell me, what would you like to see? An exponential function, I'm sorry, forgive me, a polynomial function, a rational function with a slant asymptote. What would you like? Polynomial, rational, remainder theorem, factor theorem. Any preference? Bless you. Any preference? Okay, polynomial or rational? Rational. Okay, very good. So let's choose from the rational ones. They are on page 294. We cannot do 82, but we can do 77, 78, 79, 80, and 81. Why I disregard 82 is because we need the graphing calculator extensively for that one. For the other 5, we can make it out without. Which one?
81.
81. So 81 on page 294. And we have r of x equals x squared minus 9 over 2x squared plus 1. like for any function, when I'm asked to graph it, I worry about what first? The very first thing that I need before I even think of graphing, the domain. Domain is the first, and you're right, the zeros follow that. Perfect. So how do I determine the domain of a rational function? I look at the denominator. In this case, 2x squared plus 1 is never 0. So there are no restrictions on this function. It's defined on all real numbers, and there are no vertical asymptotes. None whatsoever. So between negative infinity, infinity. Of course, I will factor the numerator, x plus 3 and x minus 3, divided by 2x squared plus 1. Because I need to find the zeros. That's my next step. Can anyone tell us when this fraction will be 0? Only when the top is 0, and that happens only when x is exactly negative 3 or 3, and also 0 has to be in the chart. So I know that this is undefined here. I'm sorry, I meant to write 0. I just said that this function is defined everywhere. Oof. 0 and 0, these are the zeros of the function. Okay, and when I put in 0 in the function, this term goes away, this term goes away. So what is left? Negative 9. Okay. And now I have to talk about the end behavior. But what type of rational function is this? Same degree over same degree. What is the horizontal asymptote in that case, if the top and bottom have the same degree? The leading coefficient over the leading coefficient. What is the leading coefficient from the top? What is the leading coefficient from the bottom? Very good. So this is 1/2. Oops, I didn't mean that. 1/2 and 1/2, which means y equals 1/2 is a horizontal asymptote. Perfect. Can anyone tell us whether this function is symmetric? When you look at this function, can you identify whether this is symmetric or not? Yes, because r of negative x will definitely be equal to r of x. What does that mean? Symmetric with respect to y-axis. Very good, even function. There is nothing else. You can find as many points as you want, but there is nothing else. Let's graph what we have, and then we'll check with the calculator. So, I'm only looking at my chart. I don't care for anything else. I'm just going to put here even, and I have everything in there. So I have negative 3, 0, and 3, 0. And I have 0, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And a horizontal asymptote of 1/2. So if this is 1, then the horizontal asymptote of 1/2 is this. Okay, so let's see if we can come up with an idea of a graph. From 1/2, approaching the asymptote, the function comes down and crosses the x-axis at negative 3, 0. It continues to decrease to this point where it turns, because I know that what I have here, I have to have a copy here. If I figure out this side, I don't have to look at the chart. I will copy it here. That's the beauty of symmetry for functions. So I want to graph this, and I don't have to look at the rest of the chart because I know the function is symmetric. And I'm assuming is this. So this is f of x, and of course I'll check with the graphing calculator, not f of x, but r of x, divided by 2x squared plus 1. So in y equals, we put in parentheses for the top, don't forget please, x squared minus 9, divided by, in parentheses, 2x squared plus 1. The graphing calculator would not know to put a horizontal asymptote of 0.5. Now I'm checking the viewing window, and x minimum, -6 will be fine, +6 will be fine, with a scale of 1, that will be fine. Y minimum, no, -4 is not good enough. I want -12. I know it's not going to go beyond. Okay. And Y maximum, I want Y maximum to be small, like 2. And so I can see what's happening here. And then hit enter. And here comes the horizontal asymptote. Now, we don't know where the inflection point is. We will study this in the next course. So as you see, this function opens downward till about this point, and then it starts opening up. It opens up till about this point right here, and then it opens down. But we don't know that yet. So seeing this, I will adjust my graph a little bit, and I'll say, well, it appears that it really changes here somewhere, concavity we say, but you don't have to do anything. I'm fine with this. In pre-calculus, I'm fine with this. So this is a better graph. Good pick. Okay. Is there anything else that we need to work on here in chapter 3? One more time. Graphing polynomials, graphing rational functions, the factor theorem and the remainder theorem, synthetic division and long division. What else would we want to review here? Are we okay with the synthetic division? Are we okay with long division? Let's look at, you choose, 35 or 36. 33 is a possibility. These are important situations. 33, 34, 35, 36, all on page 293. So please choose one. Read them and tell me which one. Before we move on to chapter 4. Any preference? 34. Okay, 34 is asking us to, where are you, 34? I went back to the end of chapter 4 already. 34, you said. Use the factor theorem to show that x plus 4 is a factor of the polynomial. So we have p of x equals x to the 5th plus 4x to the 4th minus 7x cubed minus 23x squared plus 23x and plus 12. And they want us to show that x plus 4 is a factor of this polynomial. How do I show that x plus 4 is a factor of this polynomial? What do I have to determine? Exactly. I have to find P of, excellent, P of -4. P of -4. If P of -4 is 0, then I say P of x equals x plus 4 times some other factor of degree 4. It's guaranteed that if I plug in negative 4 in this polynomial and I get 0, x plus 4 must be a factor. Since the degree is 5, the remainder here, not the remainder, but the rest of the second factor, if you want, will have degree 4. We're not asked to find it. We don't care for it. We're only asked to say, yes, x plus 4 is a factor of this polynomial or not. And that's all I have to find. So I'll have to plug in. So p of negative 4 is negative 4 to the 5th plus 4 times negative 4 to the 4th minus 7 times negative 4 to the 3rd plus, not plus, I'm sorry, negative, minus 23 times negative 4 squared plus 24 times negative 4 and plus 12. So I'm going to put this in the calculator. So, in parentheses, negative 4 to the 5th power, and then plus 4 times negative 4 to the 4th power. Of course, I always forget that. Okay, negative 4 to the 5th power, plus 4 times negative 4 to the 4th power, minus 7 times negative 4 to the 3rd power, minus 23, and multiplied by negative 4 squared, plus 24, multiplied by negative 4, oops, not that one, this one, and then plus 12. What did I do?
The second 20 or 24 to 25. It should be 23.
Oh, did I copy it incorrectly?
Yeah.
Oh, okay, I see. Okay, it's good that it's towards the end. Thank you. Ah, very good. So I'll say yes. And indeed, x plus 4 is a factor of this polynomial. We did get 0. Very good. Did we get 0? Okay, let's go to chapter 4 on page 354. I would like to choose some log equations, some exponential equations, and word problems. Let's say 67 on page 354. Log base 8 of x plus 5 minus log base 8 of x minus 2 equals 1. We want to work on this equation. What do we have to do first? I can't just yet. I have to do one more thing before. Say it again. And not yet. There is something else very important here before I proceed. X plus 5 must be greater than 0. Log will not exist otherwise. And x minus 2 must be greater than 0 because this log will not exist otherwise. And these restrictions have to be on the raw equation. I cannot touch it before I write this. Okay, so then from here I have x greater than -5, and from here x greater than 2. Obviously, the solution must be greater than 2. If I don't get a solution that is greater than 2, I will have to disregard it. Okay, now I will have to condense the left-hand side. How do I condense the left-hand side? How do I condense this side?
Log a x plus 5 minus x minus 2.
It's a difference, so this quantity has to come from the denominator. And now this is equivalent to? Is equivalent to what?
8.
Yes, a to the first power equals x plus 5 over x minus 2, which is basically 8 over 1, to indicate that this is a proportion. Very good. So then what do I do next? Very good. Let's cross multiply. So I have 8x minus 16 equals x plus 5, or 7x equals 21, or x equals 3. Is this acceptable? It is acceptable. This was a log equation. An exponential equation, please. Like 71. This is the most difficult type, I think. So, assuming we finish this chapter in the next 15 minutes, what else is left? 5 and 6 together, chapter 7, and or for Wednesday, and 11 and 12 we just covered. So we still have trig, 5, 6, and 7 to review on Wednesday. Okay. Yes, what do I do here? Because I cannot present 5 and 3 with the same base. So what is my only option? Apply natural log or log to both sides so I can bring the power down. I'm applying the inverse function of the exponential so I can bring the power down. So this will be 2x plus 1 in parentheses. If we don't write parentheses, we mess up the whole thing. Natural log 5 equals 4x minus 1 times natural log 3. Now I have to distribute this little number. It looks fancy, but it's just a number. So I have 2x natural log 5 plus natural log 5 equals 4x natural log 3 minus natural log 3. Okay, what do I do next? I have to collect the terms with x on one side and the terms without x on the other. So 2x natural log 5 minus 4x natural log 3 equals negative natural log 5 minus natural log 3. Now on the left-hand side, I cannot combine. The reason I cannot combine is that they are not like terms. But there must be a way to solve for x. What is the key word? What do I have to do in order to solve for x? I cannot divide, I cannot multiply, I cannot add or subtract. What is the only thing I have to do? It's the key word in any course. Please, factor. So x in parentheses 2 natural log 5 minus 4 natural log 3 equals negative natural log 5 minus natural log 3. And now I have x. And x equals what?
natural log 5 minus natural log 3 divided by natural log 5 minus 4 natural log 3.
Very good. Very good. Uh, 96 on page 355. Any questions? So word problem. Let's take a look. A culture contains 10,000 bacteria initially. After an hour, the bacteria count is 25,000. Find the doubling period. And part B, find the number of bacteria after 3 hours. Good. So we know that bacteria grow exponentially. And we have to remember the formula. So that will be, yes, A of T or N of T as the number, whatever you want to use, the same thing, equals the initial A0 times E to R or KT. It doesn't matter. R is the growth rate. Very good. So the initial is very clear. I already have A of T equals 10,000 times E to RT, because the first point was 0, 10,000. But what is the second point that I'm given in this problem? I'm given 1, 25,000. This is the point that I have to plug in here carefully in order to find what? What am I after? What I don't have and I need?
K.
Yes, K or R, whatever you want. Some books call it R, some books call it K. So you want to use K? I'll change it to K.
No, R is fine.
Okay, perfect. So then now, please tell me how to plug the point in here. Exactly. This is 25,000 equals 10,000 times E to R multiplied by 1. I shouldn't write it because it's not good. Now this is another exponential equation that I have to solve. How do I solve this? What do I do first? And the answer is we have to clean it up. How do I clean this up? No, it's multiplied. So first of all, I cross out 3 zeros from both sides and I divide by 10. So 25 over 10 equals E to R. And you can say, if you want, 2.5, or you simplify, whatever you want. 2.5 equals E to R. How do I solve this equation for R? Yes, I have to apply natural log. There is only one chance because I want this power to come down. Natural log 2.5 equals R. So I will plug it in the calculator. And when I do that, I get natural log of 2.5 close, and I get 0.9163. 0.9163. We normally take at least 4 decimal digits for rates. So then I go back. And I go back and I have the entire model. So A of T equals 10,000 times E to 0.9163 T. Now I have 2 questions to answer. One question is, find the doubling time. What does the doubling time mean? For the initial to double. What is double of the initial? 20,000. So 20,000 equals 10,000 times E to 0.9163 T. So what do I do to both sides? So 2 equals e to 0.9163 t. I'm after t, the time needed for the 10,000 to become 20,000. What do I do? Apply natural log to both sides. So I have natural log 2 equals 0.9163 t because natural log e is 1. Excellent. And the final here is t equals natural log 2 over 0.9163. So I have natural log 2 divided by the previous answer. Okay, I got 0.76. What does this mean? 0.76. Exactly. So less than an hour. Part B. How many bacteria were after 3 hours? So that is A of 3, which is 10,000 times E to 0.9163 multiplied by 3. So 10,000 multiplied by E in parentheses 0.9163 multiplied by 3, close the parenthesis, and I got 156,254 bacteria. The fastest growth of all functions we looked at. Okay, we have 7 more minutes. Please tell me, what would you like to work on? Anything from chapter 4 or anything from trig? Anything that you would like to work on? And on Wednesday, we'll use the entire time to continue reviewing. But what would you like to do right now? Would you like to prove a trig identity, for example? Yes? Okay, at the end of chapter 7, let's choose an identity on page 530. Verify the identity, anything from 1 to 24. And also we have to review trig equations from 31 through 48.
How about 32?
Which one?
32.
You said 30?
2.
32. Very good. So we have 32 on page 530, which is 5 cosine theta plus 3 equals 0. Very good. We're asked to solve the equation. Solve the equation in the interval 0 to 2 pi. They don't want us to put all possible solutions, but just in 0 to 2 pi. Okay. What is the first thing I have to do? I have to solve for cosine, which is negative 3/5. I have no knowledge of negative 3/5. So go back to the unit circle. And I'm asking myself now, where is cosine positive? I meant to say negative. I'm sorry. Yes, it's positive. So this is negative. Good. So I will have to determine 2 angles. One that ends in the second quadrant and one that ends in the third quadrant. Okay. Now, I don't know what this piece is. It's negative 0.6. So if this is negative 1, so negative 0.6 will be somewhere here. So one angle is this, They both have to have the same cosine, and this is the negative 0.6. This is their cosine. This number is this piece from here till here. And here's the second angle. I can determine the reference angle. I can only apply cosine inverse to 3/5. So this piece, which is the reference angle, which is also here, this piece, this angle here, and this angle here, they're both the reference angle, will be arc cosine of 3/5 or cosine inverse of 3/5. So I have to put this in the calculator. Now I have to be careful what I want. Do I want the answer in degrees or do I want the answer in radians?
Why would it be cosine inverse of negative?
Very good. Because the reference angle, yes, the reference, we're going to get to that in a minute and we're going to check. But the reference angle is always a positive angle, and the cosine sign of the reference angle will always be positive. So that's why I disregarded the negative for a second. Okay, so then here I have arc cosine, so make sure I want the answer in degrees. So I put degrees, and then I go to cosine inverse, and I put 0.6, and I get 53 degrees. I'm gonna say just 53. Okay, you can say approximately. So then theta of the reference angle, sorry, that's what I meant. The reference angle is approximately 53 degrees. So then I solve the equation. So cosine theta equals negative 3/5 results in two angles, theta equals and theta equals. If the reference angle is 53 degrees and this is 180 degrees, it's going to be 180 minus 53, one option. I'm going to write it here, 180 minus 53 degrees. And the other option will be 180 but plus 53 degrees. So 180 plus 53 degrees, this is 232 degrees. And 180 minus 53 is 127 degrees. So this is the 127, and this one is the 232. We could have not determined this without the calculator, however. We are limited. We only know pi over 6, pi over 4, and pi over 3, and the corners of the unit circle. That's all we know. We don't know what angle has cosine 3/5. We had to use the graphing calculator to determine that. Any questions?